Here's another video where the microphone was muted when I recorded, so I have to do a voiceover. Throw a coin that is a fair coin 3 times. We're going to list what the sample space is. Because there's a first, second, and third throw, we should be expressing these as ordered triples. Because we know the multiplication principle, we can also predict in advance how many outcomes there will be. 2 options for the first, 2 for the second, 2 for the third, so 2 cubed is 8 outcomes. And now we're going to see those 8 outcomes being listed. Putting the curly cube braces around all of that. We need 8 ordered triples. The first one I'm listing is one extreme event where all 3 are heads. Then I'm going to list 3 of them where there are 2 heads and 1 tail, and what I'm doing is moving where the tail shows up. At the end, in the middle, or at the beginning. The next 3 are a mirror image of that in a sense, have 1 head and 2 tails, and move around where the head appears, that 1 head appears among the 3. At the end, in the middle, or at the beginning. And then finally, the other extreme case where there are no heads, all of them are tails. You could use this to answer the following questions, or we could do some direct computations without ever seeing the sample space. So having at least 1 head, that does not mean exactly 1, it does not mean less than 1, it means 1, 2, or 3 are heads. So what I did there was I copied down the sample space, and I'm going to erase just 1 of them where there were 0 heads. And that leaves us 7 out of the 8. Now with it being a fair coin, heads has a probability of 1/2, just like tails has a probability of 1/2. I can justify this a little bit later, but all of the 8 in the sample space are also going to be equally likely. If we have x counting how many are heads, then as we saw in the sample space, we could have 0, 1, 2, or 3. This may be a little bit ahead of what you've learned in your course, but that is a random variable. X is a random variable. More specifically, it's a discrete random variable. So now what I'm going to calculate is the probability for each of those possible values of x. I could either look at the sample space, or since each of the outcomes is equally likely, not the values of the variable, but the 8 outcomes that we listed. that 8 was coming from 2 to the 3rd power. Usually when you calculate a probability, the size of the event that you would have in the numerator would be calculated in a similar fashion. But in this case, the 1, 3, 3, and 8 that we're seeing there are actually from combinations. 3 choose 0 gives you 1. 3 choose 1 gives you 3. 3 choose 2 gives you 3. And 3 choose 3 gives you 1. So this is one of the rare instances where we calculate what's in the numerator differently from what we calculate what's in the denominator for size of event over size of sample space. And so to address the probability of at least one head that's showing towards the bottom there, we could have either picked the 7 equally likely outcomes out of the 8, or for a single trial of throwing 3 of those coins, you cannot get both 1, 2, or 3 heads at the same time. You'd have to have another trial. So those are mutually exclusive events. No double counting to worry about. No subtracting to worry about. We could just add 3 eighths plus 3 eighths plus 1 eighth to get 7 eighths. So we're seeing 2 options for computing this.